Hello everyone. So today we are going to talk about direct sequence spread spectrum, we call DSS. So DSS is one of the most popular modulation and transmission method in wireless communication. So what is DSSS? So DSSS is a spec, spread spectrum modulation technique where the original data signal is multiplied by uh, pressure random noise code that has a higher frequency. This spreading code increases the bandwidth of the signal. With the spectrum, narrowband signal are intentionally spread over much wideband, and it combines data signal directly with the higher bit rate sequence. So here are the key concept. Splitting code. Spatial random sequence of speed that split the data signal over the wider frequency band. Chipping rate. The rate at which the pseudo random code is applied to the data signal typically much higher than the data rate. Modulate. The split signal onto a carrier frequency for transmission. Correlation. At the receiving end, the same pseudo random code is used to de-spread the signal, correcting the received signal with a spreading code to receive the original data. Synchronizer ensure that the pin sequence at the transmitter and receiver are synchronized for proper splitting. So how does how the SSS work? So before that let me explain you some the component like the data signal. Data signal the original data to be transmitted is represented in binary form. It's called data signal. So splitting code, spread your random code sequence also in binary form is generated. This code has much higher frequency than the original data. Splitting. The data signal multiplied by the splitting code. Each bit of data signal is XOR, exclusive OR, which the bit of splitting code. Transmission. The split signal now occupy a wide band with is transmitted over communication channel. Reception and this spreading. The receiver use the same pseudo random code to multiply with the receiving signal, which is spread. The original data signal is recovered by collecting the spread signal with the spreading code. In the other word, with the 5 components, first is signal spreading. Original data signal. The original data signal is a binary sequence, 1 and 0, that need to be transmitted. Second, PN sequence, a pseudo random noise sequence which is a higher rate binary sequence is generated. This sequence is known to both the transmitter and receiver. And third is spreading process. The data signal is XOR with a pin sequence. This process spread the energy of data signal over border frequency band, producing spectrum signal. And for the transmission, the spread signal is then modulated on a carrier frequency and transmit over the air. This wide band signal appear as noise to unintended receive without the correct PN sequence. The last one is reception and the spreading. Reception. The receiver captures the incoming spread signal, which include the original signal, noise, and interference. The spreading, the receiver used the same PN sequence to XOR the received signal, spreading it. This process correlates the received signal with PN sequence, extract the original data signal. Filtering the spread signal, which is now original data signal, plus some residual noise, is passed through low pass filter to remove high frequency noise, improving the signal to noise ratio. So at the sending end, original data present noise sequence is added and mixed in the spreading module, spreading modulator. PN sequence or PN code we just call all chip are much higher bit rate sequence, a series of 1 and 0 and 1. That chip make original data signal identical to the PN code. Close to a noise level signal, the spreading modulator distributes the transmitted signal over much wide band. And at the receiving end, this transmit signal are demodulated with PN code and original data restored. In the process of modulation, the demodulation achieved. One is bit is coded and second signals bit are distributed over wider frequency band. Now we talk a bit about XOR exclusive OR. The XOR exclusive OR operation is a functional binary operation used in digital electronic and communication system, including direct sequence spectrum, spread spectrum. In the context of the XOR operation used to combine the data signal with the spatial random noise sequence, effectively splitting the signal over wider band width. So XOR operation take two binary input and return binary output. The result is 1 if and only if one of the input is 1 and the other is 0. If both inputs are the same, both 0 or both 1, the result is 0. So you can see the picture. We have the data is 1 and 0, So the pin is according to the data input 1 and 0. For example, here is the pin. The about one is the pin. 1 1 0 1 0 0 0 1 0, and another one is 1 1 0 1 1 1 0 0 1. So to get the transmission signal, we need to calculate according to the XOR trust table. If the bit is 0, bit A is 0 and bit B is 0, so the output should be 0. If the bit A is 0, bit B is 1, it will be output is 1. So you can see the first one, data is 1. So we can calculate according to the trust table. So first one is 1, 1 is 0, and 1 1 is 0, so 0 0, and 0 1 is 0 1 is 1, 1 1 is 0, and 1 0 is 1, 1 0 is 1, 1 0 is 1, and 1 1 is 0, and 1 0 is 1. So bit 1 is we get the output is 0 0 1 0 1 1 1 0 1. And we also do the same with the bit data bit 0. The other side is the pin PIN is 1 1 0 1 1 1 0 1 0 0 1. So is according to the trust table is 0 1 is 1 0 0 1 is 0 0 0 is 1, and 0 1 is 0, yeah, 0 0, and the other is the same, is 0 0 is 1 1. Okay, so in summary, for XOR operation used to combine the data signal with pin sequence, splitting the signal over wide frequency band. Splitting involving XOR each bit of data signal with pin sequence. Data splitting, the receiver use the same pin sequence or XOR with the receiving signal recover the original data. The XOR operation is a key component of DSSS, enabling the signal splitting and the splitting process that make communication robust, secure. So here is the application of DSSS. So it used for wireless, used in the early Wi-Fi standard for robust wireless communication, and used for CDMA, employed in cellular network to allow multiple users to share the same frequency band without interference, and used in GPS, utilize DAS for accurate and reliable signal transmission, enhancing the robustness of GPS signal. By spreading the signal across the wider band, DSSS improve the reliability, security, and performance of wireless communication system, make it a fundamental technology in modern wireless communication. So here is some advantage or benefit is one is resistant to interference. The wideband nature of a split signal make it more resistant to narrowband interference. Enhance security. The signal appear as noise to unauthorized receive without the correct pin sequence, providing level of security. Multi-part resistance. DAS have mitigate the effect of multi-part interference where the signal reflect off surface and arise a different time, improving signal clarity. So, in the other hand, we can see that more benefit is more bandwidth. Second, encode data. Third is low power density and noise light signal. So that's three benefits would explain why split spectrum technology and DSS were developed and used and are still used in military communication in the first place. So that's all for the SSS, direct sequence split spectrum. Yeah, thank you.